Hi guys, so this is the last video for our complex number unit. We're going to look at the absolute value of complex numbers. And so to find that, well, first of all, let's look at what the absolute value is. The absolute value of a complex number a plus bi is the distance from the origin to the point AB in the complex plane. It's denoted with regular absolute value symbol bars, the absolute value of a plus bi, and it's equal to the square root of a squared plus b squared. So let's look at an example and why it is equal to a squared plus b squared, the square root of that. So the absolute value of 3 plus 4i, first of all, let's plot 3 plus 4i. So you're going to go 3 units in the real direction and 4 units in the imaginary direction, and there's our point. And so now what we're going to be doing is finding this distance right here. And so this formula right here comes from the Pythagorean theorem, which says a squared plus b squared equals c squared for any right triangle. So I can create a right triangle. I went over 3 units in this direction and I went up 4 units in this direction. And so what we're going to do is this is going to be 3 and this is a distance of 4 units. So we're going to this is going to be my A in this case is 3 and B is 4. So by the Pythagorean theorem, this is the distance we're trying to find, and if you take 3 squared plus 4 squared, you'll end up with this distance squared. I'll call it C. You end up with C squared, and so in order to find C, you would take the square root of both sides. So in general, it's a squared plus the square root of a squared plus b squared, and not just 3 and 4. Okay, so then to calculate the absolute value, we're going to put that in here. So I already did it over there. So it's 9 plus 16. So then that equals 25, and the square root of 25 is 5. So the absolute value of 3 plus 4i is equal to 5. All right, so go ahead and try to do numbers 21, 22, and 23, and then check back to see if you're doing all right. All right, for number 21, you should get the square root of 82. The work is shown right here. Your A value will be 9, and the B value is the number in front of the I, which if there's nothing there, it's a 1. So A is 9, B is 1. Plug it into the formula, you should get the square root of 82. For number 22, there's no A value this time, so A must be 0. And so the work is shown here. B is negative 5. When you throw it into the formula, you get 0 squared plus negative 5 squared, which is 0 plus 25, or the square root of 25, which is 5. And then last but not least, we have 23. The A value is 1, the B value is negative 2, and when you put that into this formula here, you get the square root of 1 squared plus negative 2 squared, which is 1 plus 4, which equals 5, and the square root of 5 we're just going to leave as the square root of 5. Of course, if it's a square root that can be simplified, you should simplify it. All right, so that is the lesson for 2.5 and 2.9 in corresponding with your textbook. Bring any questions that you have to class. Oh, there's one more thing I wanted to show you, and if we look at number 22, just so you see how this works, you've got, if you plot the complex number in the complex plane of negative 5i, the a part is 0, so you're just going to drop down here. So that would be, for number 22, that is negative 5i plotted on a complex plane. And if you think about the distance from there to there, it would be 5 units. So it's a little bit more work to find it if it's at a diagonal. But if it's on an axis, you should be able to just count how many units it is from the origin. Okay, that's that.